Okay, so I'd like to welcome Dr. Steve Jenkins from Xeros Cleaning to talk to us about polymer beading. Thank you.
Thank you very much. Good afternoon. So picture the scene. You're walking through an alpine pass. It's a lovely day, glorious, 80 degrees. You come across a crystal clear lake of lovely, clean water. What do you want to do? Do you want to go for a swim? It's a good idea. Do you want to take a drink? Also a good idea. And I hesitate to ask this question in front of this audience. How many of you thought, as your first reaction, that's handy, I'll do my laundry? Congratulations on your work-life balance. You have achieved a positive result. Okay. What are we about? We are about letting you do more of the drinking, more of the swimming, and less of the water consumption in laundry. Our beads are there to replace the water. We replace 80% of the water in commercial washing processes. We are washer extractor based, and when we talk about low temperature, we're talking about 20 degrees C. So ambient capability, very good stain removal. And I'm going to talk through some of the science about how we do that. Sorry, Chief Science Officer, the clue is in the title. Do apologize. Okay. So this technology is applicable to a whole range of industries. I want to start off by just scoping out where Xeros is actually having an impact. And obviously I'm here to talk about laundry, but you can see from the slide that we're also into other applications, and one of them is leather tanning. So very briefly, just talking about how beads are used in the tanning process and how they're used to make leather in a much more efficient and environmentally friendly way. The parallels with laundry are quite marked. This is a large drum-driven process in which we put polymer beads, and we reuse the polymer beads many times. If it takes 30 tons to produce 1 ton of leather today, with our process it takes 6. It's again an 80% rule of thumb. So we're looking at platform technologies across laundry, across leather, and across other industrial and commercial applications to come. But I want to focus on laundry. Our stand down there at stand 38 has some examples of some of the fabric shrinkage and shape retention and color retention benefits you get from our process. But our setup is basically along these business lines. So first of all, differentiated outcome. We are a very sustainable cleaning technology. Low temperature, 20 degrees, low chemistry. Because we use less water, we use less chemistry to get the same concentration and to get the same cleaning efficacy in the drum. We do actually promise a superior clean to conventional processes at the same temperature. And I'll explain how we managed to achieve that in a moment. And garment life, fading, shape retention, color retention. We are a very gentle cleaning process. A lot of people hear polymer beads and think we are sandblasting or abrading the surface of the cloth. Completely the opposite, and we'll talk to you about that in a moment. How do we provide our technology? We provide our technology by leasing you the machine. You're perfectly capable of buying it outright, of course, but we tend to run a 5 to 7 year contract, and there's a man at the back that can talk to you about all the commercial terms that you need to know in how to do that. We provide you with the beads and the chemistry, and you run our technology. We'll service and maintain the machines. It's over a 7-year period. We are an AIM-listed company. We are stock exchange listed in London. We have 200 plus installations in the US. This statistic slide behind me is actually talking about our US market. Briefly come on to talk about our UK and European market in a moment, but targeting basically hotel and lodging, retail dry cleaning, and industrial laundry. And the example I've got of our technology today is mostly around industrial laundry. You can see a picture at the bottom. That's an installation in a hotel in the US with 3 of our washer extractors in place, and some nice quotes for some happy customers. And we're moving into the laundromat arena, and we're looking to put a smaller machine on with our 25 kilo washer extractor, which is our standard offering at the moment. There is a 16 kilo version of that coming to the market very shortly. This is where we are in the US. It's either a customer, it's a forward channel partner, it's a Xeros representative, and you can see from where the water is scarce, where the color is dark red, that's where we focus our attention for pretty obvious reasons. We also focus it down the eastern seaboard. There's a lot of water scarcity there. There's also a lot of high capita income. How does it work? So we've already had a reference to Sinner's Circle. Sinner's Circle has not gone away. It's been modified a little bit. So what we have is now a polymer bead. So just to put this into context, the machine you can see down there at stand 38 has got about 1.5 million polymer beads in it, which are about 4 to 5 millimeters in diameter. These things are made of nylon, and they are there for a very specific reason. They're there to help break this sinuous circle into its constituent components and help it out in terms of cleaning performance and ability. So I've taken 80% of the water out of the machine. I can wash 25 kilos of wash load with 115 litres of water in total. 2 domestic wash loads basically, and we're washing 25 kilos plus to very exacting industrial standards. The beads provide mechanical action, first point. So they are there to roll around with the cloth. They will move over the surface of the cloth and they will get between the individual pieces of cloth in the drum. That has a number of benefits. First of all, it separates the cloth from itself. So basically you don't get a lot of friction between the cloth. You get friction between the bead and the cloth. And secondly, when you actually come to take the wash load out at the end of the process, and of course all the beads have been removed by that point, you are lifting individual pieces out. You're not lifting a massive lump of stuff that's tangled itself and creased itself and damaged itself as it would in the conventional process. Mechanical action, the rubbing of the surface of the beads, is a surface-driven effect. It's very gentle. It's extremely uniform. It gets everywhere. If you look at conventional machines where things can fold and things can trap, they can't do that in the Xeros process because the beads get in the way, in a good way, and they keep things apart so you can wash in a much more uniform and controlled fashion. They also have a chemical effect. Our latest beads have chemistry in them that's actively dosed into the wash load. The basic bead, the first generation bead, which works very, very well indeed still, has its own ability to attract dye. So if you take nylon and if you wash it, you'll notice it gets grey very quickly. That is this process in action. So the nylon is absorbing the vagrant solubilized stain in the wash. It's absorbing the dye that's coming out of wash loads, and it's making sure that your garment is better protected in terms of dye transfer inhibition, as well as all the other benefits that I've mentioned earlier on. So what's the result of all this? Well, you're saving a lot of money, which is always a good thing, but you're getting a good uniform wash over the entirety of your wash load. You're getting it at low temperature. It's a very, very effective process. You're cutting grease at very low temperatures indeed. And you're getting a process which is, with the beads being recycled and reusable, one of the most sustainable washing technologies that there is to have. That's not something you expected to see when you came to this conference. That is a nylon molecule. And on that molecule, there are various bits that are charged. So if you look at the red, that's the oxygen. If you look at the blue, that's the nitrogen. And those are slightly differently charged. And all stain is in your process is a slightly charged molecule. So when you've got positives and negatives along that backbone, it's an electrostatic attraction of stain that's in your wash load. It will stick to the surface of the nylon. It will then absorb into the nylon if it's solubilized and onto the nylon surface, because the nylon has an ability to open up like a sponge at very low temperatures. At 20 degrees C, this thing is sucking dye into itself and trapping it into itself, and it's holding on to that for at least 500, probably 1,000 washes before you need to start thinking about recycling the beads. It's a very clever molecule. And then beyond this, as I said, we're going further with new technology to actually put chemistry in there so it will dose and it will take chemistry right to the surface of your cloth. So if you do that, you can imagine if you've got a conventional machine with a dip level, that you've got a lot of water in there, you've got chemistry in there, and then that's got to reach a critical solution and its concentration, and it's got to get to the surface of your cloth. If you put that on the bead that's taking that chemistry right to the surface of the cloth and effectively rubbing it in for you, it's a much more efficient use of chemistry. And you can do that over and over and over again. 500 to 1,000 cycles, the beads are stored in the machine, they're reintroduced, they work, they go back, and we keep carrying on. The beads are circulated through the drum. Think of it as a shower of beads going through the drum, as opposed to swimming in water, which is the equivalent of taking a bath, I guess. So, all sorts of claims. Please go down and discuss with Tony, who's at the back, the basis for those claims. But I wanted to focus very briefly on just one more topic, which was the rewash side of things, so industrial laundry. So if you choose to save water, to save chemistry, to save temperature, you can do all of that. If you also choose to try and recover more linen, and you want to save less water, less temperature, less energy, you can do that too. What you're doing is just boosting the cleaning power of what you've got in a washer extractor. So it's been through your tunnel, didn't clean. It's been through a wash extraction process. It's gone to 90 plus degrees, didn't clean. If you put it in this system, 70% of what you put in will come out clean. It is a different mechanical action. It is a different surface effect using this process compared to standards. We've had this peer-reviewed. LTC have actually helped us out. We've also done an over a 10,000 article trial with a major customer in the UK and verified these data. And these data basically are 55% better than a conventional process in terms of the average recovery rate. The bottom line in terms of saved linen and extended linen lifetime, 35,700. There's a man at the back there that can justify that figure to you and be happy to do so. And linen life extended by 7 rental placements. So I'm talking about a more sustainable, powerful cleaning process than conventional. And at the same time, we're being gentler to linen. It is a complete reversal of what the conventional thinking is in terms of cleaning performance. And it is because of this disruptive technology, this use of beads rather than water, that we can achieve this. So I'm happy to take questions, but just to say really that we are driving into commercial and indeed into domestic laundry in the not too distant future. We've got medium-term aims in leather processing, and we will be putting this into a whole host of other substrate cleaning technologies going forward. It is a platform technology, and laundry is one of our platforms. Hence, I'm here today.
Thank you very much.
You're welcome.